So most, or I would say half of the quiz is log and exponential solving equations. So similar to the quiz, but more like the solving questions on the quiz. So it's not that you don't need to know how to expand and condense. There's not going to be any questions that ask you to do that, because you may have to do that in order to solve, but they're solving questions. And then the second half of the other half of the test will be 8.1, where we found the derivative of exponential functions and the integral of exponential functions. So we're going to look at the first half of the review has a lot of the log questions, so we'll do these first. But these questions are similar to the quiz, so use your quiz, the solving questions from the quiz, to help you study. So looking at number 2, when we solve for x, we always want to get the base with the exponent all by itself first, so I can divide both sides by 4. So we get 3 to the power of x is equal to 20. What would I need to do next? We can put it in log form. So I could take the log with base 3 of both sides. So it'll cancel here. We get x is equal to log base 3 of 20. If you rearranged it and put it in log form, you'll end up with the same equation. Then to put this in the calculator, we have to use our change of base formula. So we have log of 20 divided by log of 3. Remember, the base goes on the bottom. So then we put this in the calculator. Make sure you use parentheses, especially if you do it all at once. So you should get 2.7268. So I'll call it 27. We'll round to 3 decimal places. It'll be specific on the test how many decimal places it wants. Next, let's look at number 4. So again, we want to get the base with the exponent all by itself first. So I'm going to subtract 11 on both sides. So we get 5 to the power of x is equal to 50. What should we do next? Put it into log form. So I'm going to take the log base 5 of both sides. So it'll cancel. We get x is equal to log base 5 of 50. Then when we put this into the calculator, this would be log of 50 divided by log of 5. So x is equal to 2.4306, so 2.431. So you could either take the log base, whatever your base is of the exponent of both sides, or rearrange it. You'd end up with the same thing. Let's do 5. So I'm going to divide by 1200 on both sides because we want to get the base with the exponent all by itself. So e to the power of negative 3x is equal to 90 divided by 1200. So we'd get 0.075. Then, what do we do to get the x out of the exponent? Awesome. Since we have an e, we're going to take the ln of both sides to cancel out with that e. So then we're left with negative 3x is equal to the ln of 0.075. So I'm going to take the ln of this. We should get negative 2.59. It keeps going, but I'm going to leave it in the calculator for the last step. What's our last step? Divide by negative 3. So we should get 0.863. Next, let's look at 7. So here I have an ln equation. I'm going to rewrite it here. How do I get rid of the ln? Make the big base e on both sides. If you want to change it to log base e and then put it into exponential form, you could do that. But we can take the big base e on both sides. So I have e to the power of 5.1 is equal to, this cancels, so it's equal to 9x. From here, we're going to put it in the calculator. So e to the power of 5.1. We should get 164.02. It keeps going, but I'm going to leave it in the calculator for the last step, which is to divide by 9. So we'll get 18.2246, which would round to 5. How do we get rid of the ln in 8? Make the big base e on both sides. So same thing that we did in the last one. E to the power of ln is going to cancel, so we're left with the square root of x minus 5 is equal to e to the 4th power. So we can find out what e to the 4th power is in our calculator. We get 54.59. It keeps going, but I'm going to leave it in the calculator. What would we do next? How do I get rid of the square root? Square both sides. So I'm going to square this in the calculator. We get x minus 5 is equal to 2,980.9579, so 0.958. It keeps going, but just leave it in your calculator. And then we can add 5 to both sides. So x is equal to 2,985.958. What would we need to do for something like 9? Factor. Awesome. This looks like x squared minus 5x plus 6. But instead of x's, we have e to the power of x. So instead of factoring it into x plus our number and x plus our number, it will be e to the power of x plus our number. So what are two factors of 6 that add to negative 5? Negative 2 and negative 3, perfect. So e to the power of x minus 2 and e to the power of x minus 3. So then we're going to set each one of these equal to 0. E to the power of x minus 2 equals 0. E to the power of x minus 3 equals 0. And solve each of our little equations here. E to the power of x is equal to 2. What would I need to do to solve for x from here? ln both sides. So ln of e is going to cancel. We're left with x is equal to the ln of 2, which would be 0.693. Let's do the same thing with our second little equation. We're going to add 3 to the other side, and then take the ln of both sides. So ln of e cancels. We're left with x is equal to the ln of 3, which is 1.0986, which would round to 9. So for 15, we want to find the derivative. Be super careful. Make sure you know the difference on how to find your derivative of your exponential function and your antiderivative of an exponential function. So just be careful, don't rush it, know the difference between the two. Here, when we find our derivative, since it's squared, we could either write it twice and FOIL it out, or we could use our chain rule. Think about it as if this was x plus 2 squared. We could use our chain rule. Our chain rule is we take the derivative of the whole thing, or the outside. So I'm going to multiply by 2 to the front. The inside stays the same, so 2 minus e to the power of negative x. And then we subtract 1 from the exponent. So this would now be the first power. Then we have to do the derivative of the inside. So our derivative, multiply it by the derivative of the inside. Our derivative of 2 would just be 0. Our derivative of negative e to the power of x would stay the same. It'd be negative e to the power of negative x. And then we have to multiply it by the derivative of the exponent. So when we take our derivative of an exponential function, the e stays the same, and then we multiply it by the derivative of the exponent. So times, what's our derivative of negative x? -1. Perfect. To simplify this a little bit, I can multiply the 2 and my negative e to the power of negative x times -1 together. So this would be 2, it turns positive, e to the power of negative x times 2 minus e to the power of negative x. You don't have to distribute it, but this would be our derivative. I'll go back to 1 and 2 so you can write them down if you want, but let's do 3 first. How would I take the derivative here? What would we have to do? Awesome, the product rule. So our product rule is the first times the derivative of the second plus the second times the derivative of the first. So our first term would be x, and our second term is e to the power of x squared. So our first would be x times the derivative of the second. So our derivative of our exponential function here would be e to the power of x squared. It stays the same. And then we multiply it by the derivative of the exponent. So what's the derivative of x squared? 2x, perfect. Plus the second, so e to the power of x squared, times the derivative of the first. What's the derivative of x? 1. Awesome. So to write this a little bit better, we could say 2x squared when we multiply x times 2x times e to the power of x squared plus e to the power of x squared. So this would be our derivative. Just for fun, let's say this question said to find our critical numbers. What would we have to do to find the critical numbers? Set it equal to 0. Perfect. We set our first derivative equal to 0. So when we set this equal to 0, typically when you have your e's, when you have exponential functions here, you want to take out your GCF. So always look and see, do I have a GCF in my terms? Do we have a GCF? What's our GCF? E to the power of x squared. So we're going to take that out. So I'm dividing out e to the power of x squared. And we're left with 2x squared plus 1. What would we do next? Set them both equal to 0. Perfect. So e to the power of x squared equals 0. 2x squared plus 1 equals 0. How would I solve the first one? E to the power of x squared equals 0. What do we do? Take the ln of both sides. What is the ln of 0? Does not exist. We do not get an answer from this one. You can try it in your calculator. You'll have your calculator with you. Do the ln of 0. It'll give you an error. Does not work. Let's do the second one. I'm going to subtract 1 on both sides. So 2x squared is equal to -1. Divide by 2. X squared is equal to -1/2. What would we do next? Take the square root. So x would equal what? Does this give us an answer? No, does not exist either. We have an imaginary number, so we don't get a value here either. So do we have any critical numbers? No. Remember, critical numbers give you your relative extrema. So hypothetically speaking, let's say we had 5 as our critical number. Remember, we said we don't get one here. We have no critical numbers, so we don't have a max or min here. But if we had 5, just to work it out, I think there's another question on the review, but we'll practice this one. We'd have our intervals from negative infinity to 5 and from 5 to infinity. We'd have to do the first derivative test. So plug in a number in our first interval. Find a number in our first interval. Plug that into our first derivative here. So we could plug in 0. Do the same thing with the second interval. So here we could plug in 6. See if it's positive or negative. If this was positive and this one was negative, meaning that we were increasing then decreasing, what would my point be? A relative max or min? A maximum. I would have a relative maximum at 5, comma. How would I find my y value? Plug it into the original function. So we'd want to find f of 5. So we'd plug it into the original. So you're doing the first derivative test. You want to plug into the first derivative to find if it's increasing or decreasing. But to find your y value, you plug it into the original function. So this is just hypothetical. Make believe. Just a made-up problem. When we're taking the antiderivative or we're doing the integral, you want to use u's. U's are going to be helpful here. You don't have to. In all the derivative questions that we just did, we didn't use u's. So you don't have to when you're doing the derivative, but for integrals, it's going to be helpful. It's going to keep you organized. So let's let u be our exponent, 2 to the power of x. So what would du have to equal? 2 dx. Perfect. So I've got a dx there. I need to put a 2 in here so I can multiply by a 2. But if I multiply by 2, what else do I have to do? Put a 1/2 on the outside. Perfect. Got to keep it balanced. If we multiply by a 2, got to also multiply by 1/2. So now 2 dx is going to turn into du, and 2x is going to turn into u. So I have 1/2 times the integral of e to the power of u du. The exponent.
Oh, the exponent, and then du would just be the derivative of the exponent?
Yeah. So for these, it's not all the time that u is going to be your exponent. It depends on what the question is. So I think for the one from the homework here, for 14, since we had e to the power of x here and e to the power of x in here, you may want to make 1 minus 6e to the power of 2x your u, and then figure out what your du is. So sometimes you're going to have to use substitution where your u is not just your exponent. But that's only if you have like multiple e to the power of x's in your function. So our antiderivative, or our integral of e to the power of u, is just e to the power of u plus c. We don't have numbers here, so we're not plugging in anything, so make sure you put your plus c. And then we have that 1/2 on the outside that we need to plug in, or we need to include. And then lastly, I have to make sure I put the x's back in. You don't want to leave u's in your answer. So here we have 1/2 times e to the power of 2x plus c. So this would be our integral. How could I check my work to see if I did it right? We could take the derivative. Take the derivative of your answer and you'd end up with your original question. So with your integration questions, you're taking the interval, you're doing the antiderivative. You can always check your work by taking the derivative. You'll end up with your original function. Any questions here? All right, let's do number 2. So let's make u our exponent x squared. So then what would du equal? Two x dx, perfect. So I've got an x there and a dx, but what am I missing? 2. So if I put a 2 in here, I also have to do what? Put a 1/2 on the outside. So now I have a 2x dx on the inside that I'm going to substitute the du into. And I am going to make u my exponent. So I have 1/2 times the integral of e to the power of u du. Our goal is to get it to be e to the power of u du because we know our integral of it is just going to be the same thing. It's going to be e to the power of u plus c. Since we have that 1/2 on the outside, we're going to make sure we include that in our answer, and we have to substitute our u back in. So we're going to plug in x squared into the u. So this would be our answer. So we said for 14, since we have multiple e to the power of x's going on, let's call whatever's in our parentheses our u. So we have u is 1 minus 6e to the power of 2x. What is our derivative of 1 minus 6e to the power of 2x? Negative 6e to the power of 2x times the derivative of our exponent, which would be times 2. So we have negative 12e to the power of 2x dx. So I have e to the power of 2x dx, but I'm missing a negative 12. So if I put a negative 12 in here, what else do I have to do? Put a negative 1 over 12 on the outside. So now negative 12e to the power of 2x dx is going to change to du. And 1 minus 6e to the power of 2x is going to turn into u. So we have negative 1 over 12 times our integral of u squared du. And what's our antiderivative of u squared? Awesome. 1/3 times u cubed plus c. And then we still have to multiply this times negative 1 over 12. So we get negative 1 over 36. Don't forget to plug back in your x's into the u. So we have 1 minus 6e to the power of 2x cubed plus c. So this would be our integral, our antiderivative here. So for 16, we want to find the extrema and the points of inflection, if any exists, of the function. So to find a relative maximum, just like we talked about in that last example, what would we have to do? Find the derivative and set it equal to 0. Perfect. Let's find our derivative first. So if we want to, we could separate this. We could call it e to the power of x over 3 minus e to the power of negative x over 3. Or we can just take out that 1/3, put it on the outside. So I can pull out this 1/3, leave it outside, and we're going to find the derivative of the top part here. We just have to remember to multiply that 1/3 to our answer. So we're just taking the derivative of e to the power of x minus e to the power of negative x. So starting with e to the power of x, what is e to the power of x? E to the power of x, perfect. Minus, what's the derivative of e to the power of negative x? So remember, it stays the same, e to the power of negative x times the derivative of the exponent. What's our derivative of the exponent? Negative 1. So here I have 1/3 times e to the power of x plus e to the power of negative x. So this would be our first derivative. How would we find our critical numbers? set it equal to 0. So when we set it equal to 0, we can multiply by 3 on both sides, get rid of the 1/3. So we have e to the power of x plus e to the power of negative x equals 0. Just like we did in that last example, let's take out a GCF. What's our GCF here? What do they both have in common? E to the power of x. So we're going to take out an e to the power of x. When we're taking out a GCF, we're dividing it out of the functions that we have there, out of our terms. So e to the power of x divided by e to the power of x would just be 1. Now we got to think about it a little bit more here because we have a negative exponent. When I'm dividing, let's say I had x squared over x, and I'm dividing. What do I do to the exponents? Subtract. So we'd have negative x minus x from the bottom. So this would turn into e to the power of, what's negative x minus x? Negative 2x. So it's a little bit of algebra that we did there. Just looks a little bit more challenging because we have e's instead of just x's and numbers. So from here, let's set each term equal to 0. So e to the power of x equals 0, and 1 plus e to the power of negative 2x equals 0. E to the power of x equals 0, what would we do to solve? Ln both sides. So it cancels there. We get x is equal to, what's the ln of 0? Doesn't exist. So don't get an answer there. No critical number from there. Let's do the same thing with the other side. We're going to subtract 1. So we get e to the power of negative 2x is equal to negative 1. What would we do from here? Ln both sides. Can I take the ln of negative 1? No. Can't take the ln of 0. Can't take the ln of a negative. So this one doesn't give us an answer either. So do we have any critical numbers? No. No critical numbers. So that would mean we have no max or min. To find the inflection point, let's find our second derivative. So I'm going to take the first derivative that we have here and do the derivative again. So for our second derivative, I'm going to keep that 1/3 outside. Then we can take the derivative of each term separately. What's the derivative of e to the power of x? E to the power of x. Perfect. And then our derivative of e to the power of negative x would be e to the power of negative x times the derivative of the exponent. What's our derivative of negative x? Negative 1. So times negative 1. I'm going to rewrite this for us here. We have 1/3 e to the power of x minus e to the power of negative x. How would we find the inflection point? Set it equal to 0. Perfect. Set it equal to 0 and solve. So we could solve this the same way we did in the last one. We'll work it out. We can multiply 3 on both sides, get rid of it. We have e to the power of x minus e to the power of negative x equals 0. Let's take out our GCF. So we're going to take out an e to the power of x. We're left with 1 minus what? Awesome. E to the power of negative 2x. So we're going to set each one equal to 0. When we ln both sides on this one, it doesn't work because we end up taking the ln of 0. Let's do the same thing with our second term. We got to move the e to the other side. So I have 1 equals e to the power of negative 2x. We can take the ln of both sides here. Can I take the ln of 1? What is the ln of 1? If you don't remember it, put it in your calculator. What's the ln of 1? 0. The ln of e cancels, so we're left with 0 is equal to negative 2x. Divide both sides by negative 2. X equals 0. So that would be our x value in our inflection point. How would we find the y value? Plug it into the original. We're finding f of 0. I'm going to do that over here. So we have f of 0, e to the power of 0 minus e to the power of negative 0 over 3. What's e to the power of 0? 1. Minus what's e to the power of negative 0? 1. So we have 1 minus 1 on top, which would be 0 over 3, which is 0. So our inflection point, since this was the second derivative, is 0, 0. Looking at 17, we're just going to take the first derivative of this one, just to practice. So when we take our derivative, we're going to take the derivative of each term separately. If we were multiplying by an x, let's say this was 6x that we had here, we'd have to use the product rule. But since it's just a constant, we don't have to use the product rule. We can just treat this as one term. So our derivative here would be 6 e to the power of negative x. It stays the same. Times the derivative of our exponent. What's the derivative of negative x? Negative 1. Then minus, let's do the same thing with our second term here. We have 3 times e to the power of negative 4x, so it stays the same, times the derivative of the exponent. What's the derivative of negative 4x? Negative 4. So we can simplify this a little bit more. That would give us negative 6 e to the power of negative x, and then plus 12 e to the power of negative 4x. So that would be our answer. We do the second derivative, you're doing the same thing. So you just take the derivative again.